My idea in all the talks is always to make some demos, some live demos. I was praying yesterday to the demo god, but the internet doesn't seem to be as good as I would like. I have kept anyway many local things, so it should be fine. And yeah, that's my ego slide. I'm an IT consultant and part of the Google Developer Expert program. This here is my Twitter ID, so you can follow me there. I will post all the content of the talk, slides, source code, and you can at any time write me. I'm at the moment living in Munich, in Monaco di Baviera, which is the northest Italian city in the world. And this is the agenda for today. I will give some introduction. I have chosen 3 major topics to talk about secure development. One is file storage. How can we store safely our information in a device, tokens, files that are relevant with personal information? How can we secure the network communications? I will also show you a few demos on how can we intercept data and be able to see it, how this can be prevented, and a big part on reverse engineering and obfuscation, showing also examples of making some code injection into APKs live and doing it maliciously, so you can get an idea on how an APK can be modified to implement some behavior that is not desired by the developers. So first, external storage versus internal storage. Traditionally, when we are working with Android, we need to store information on the device, right? It can be personal information, security tokens to communicate with the server, passwords, etc. I like this analogy to talk about external storage and internal storage. When we are storing things externally, that means traditionally on an SD card. Not all the devices have an SD card, right? But most of them have. Calling this function, get an external storage directory, is like parking a car on the street. All the apps can access your files. There is no limitation. Files may not be removed or uninstalled, and the SD card can be removed, stolen, and we can access the information that is inside. As an example, if you are into forensics, now WhatsApp is, recently they announced, right, that they are encrypting all the information, but before they were not encrypting all the information, and they used to save the conversations on the SD card without encryption. So anybody could remotely access those conversations, send them per email, and encrypt them. Voila, you have access to the entire set of conversations of a device. On the other hand, get files there. It's like parking on your own garage. You're the only one that have access. No other apps are generally able to get into this control environment. Generally means in most of the cases, but there is of course a case. Somebody knows here when we can access the internal storage in a device? Somebody? When? No? Okay, when the device is root, we pretty much can access this internal storage. So if we are using the emulator, this can be used if you want to test your own application. You can just install on an emulator and see access exactly and see what an attacker could see on the application you have programmed. Reverse engineering. Reverse engineering is defined and obtaining source code from a compiled binary. When we are working with our Android application, we work with our SDK, traditionally or typically Android Studio. Some people say they use Eclipse. We compile into an APK, and this is the process of going back to the source code. Why Java? Well, Java is partially compiled and then interpreted. The number of opcodes and the Java virtual machine codes are fixed. That means they cannot be extended. And it's just a very limited number of instructions. There is no real protection against Java, not only Android, but also the Java applications. In one of the demos, I will show you with Dex2Jar, how can we very easily compile a Java file and open it. And why Android? Well, that's the Droidcon. Probably that's the first reason. At the top of that, because it's very easy to decompile Android. We can download APKs very easily from any source on the internet. Obfuscation is not always happening by default. That means we need to make active our ProWare file or our DexWare. If we're using another platform, we need to specify which folders we want to encrypt, take some files out, etc. And the translation from APK into a jar file is extremely easy. There are some legal issues. We are going to talk today about secure development, and of course, we cannot do many things live because we could get into legal problems. But there are a few points we can always explain at the beginning. Things that we cannot do. We cannot decompile an application, recompile it, and then pass it off as if it would be our own application. For example, it's very common that people download games. They recompile them, upload them for free into a pirate website with some advertisements. You can easily inject advertisements into any applications, and then it's profit for them. That's obviously illegal, which is the next point. You cannot try to sell it as if it would be your own application. If the license agreement, this thing that we always click yes, but we never read, says that you cannot decompile the application, we cannot decompile this application because we have agreed on a license. And we cannot decompile to remove a protection mechanism if our purpose is economical. If we try to skip a serial number, for example, that's illegal. But we can decompile an application to understand the interoperability. That means to see how we are interfacing to create a program that can interface with the application. Eventually, even to learn, we can uncompile big applications of big manufacturers to see how they are working and which libraries they use, etc. But we cannot do that if we want to make a profit of that. There are different purposes always. We have here the bad ones, the traditionally bad purposes. It could be very traditional in video games when you see that in Candy Crush that there is an unrealistic score, or in any other game that traditionally has been done by cheating or by a very addicted person, generally by cheating. It's very easy to see how the score is being stored. Traditionally, it's being stored locally. This can be manipulated. We can see the HTTP calls that are being sent. We can see the token, and we can just submit our own score. There is not many, generally nobody, or a few applications are applying real mechanisms of protections. We can also see privacy leaks. This is every 3 or 4 months is done with WhatsApp. There is a new study showing how can we manipulate the conversations, how can we substitute another person, how can we steal personal data, etc. And as malware, it's very, very easy to inject code. There was even the case of Irish guy that took, do you know Swift keyboard? How many people know Swift keyboard? Okay, so there was an Irish guy that took Swift keyboard, and as a proof of example, he inserted a keylogger and sent all the information that the people that was downloading this illegal Swift keyboard was typing. He substituted everything with the stars, every 10 characters, so because obviously there was like passwords and credit card numbers and etc., but he proved how this can be done in pretty much a day. And there are, of course, good reasons to use reverse engineering. Educational, we can use it to learn how others are programming. We can also research bugs, even on our own applications, and we can interface. Some applications are closed, so we can see, okay, how are you sending things to your server? Which calls are you using? I would like to interface with your application. How to obtain them? I have put here 4 examples. There are probably more. You can pull it from the device. If the device is root, you just can connect the device to the ADB pool, and the APK name, and then you have it on your laptop. You can use the Google Play Python API. It's an API that you can download and pretty much authenticate, send your request, download the APK. Alternative sources, if you go to Google and type something like download APK, you will have 100 websites. And with a sniffer, if you use Wireshark, you just can put your Wireshark between your device and the Wi-Fi network and capture the APK when it's being downloaded. Of course, we can protect ourselves against reverse engineering. There are a few suggestions or solutions you can think of. For example, you could write 2 versions of the same app. One that is free and contains a part of the application, and the other one that is full and contains the entire logic. Obfuscation. I like to grow this here because obfuscation at the end it's a partial solution. We know that obfuscation is something that is not the goal key to prevent obfuscation, to prevent reverse engineering, but it stops and slows down a lot prospective attacker. We take the code, we totally change it and interlace it, we create fake functions, so it's very difficult to read. We can use web services, which is in general a good practice. An application should be light and should handle not a lot of logic. Everything should be sent from the web service, but we can try to store as much information as possible on the cloud. Not to protect from reverse engineering, but to be able to identify that and to prove it if there is any legal issue. We can use fingerprinting in our code, using some kind of mechanism to demonstrate that the code has been written by ourselves. And we can use ND key or native methods to store information, such as tokens to communicate. ND key is not decompilable directly, so the code is much more safer there. Now let's gonna start with a few demos. I hope the internet is a little bit better now. Let me make a next check. Well, one of the first demos I wanted to make was with the emulator. So in a program, very small program I wrote called SnapHack. This SnapHack application can take pictures, encrypted and not encrypted. For that, I'm using a framework from Facebook called Council. Yeah. This one from here. It's great if you want to encrypt any type of information. It can be images, it can be strings, it can be absolutely everything, text files, whatever. And as an example, I can take here with this program a photo. This photo will be a normal one, not encrypted, if it's working. Well, because I know those things can happen, I already took some pictures that I can show you, but let's try to open it again. Okay. Well, now that we are here, I might show you also the login. This is a web service I wrote very easily to make the login. So now we have login. And that's very cool, because I can actually, I can show you here how it works when we are calling to a web service that is not encrypted. So this is Charles. Do you know how many people here knows Charles? Okay. For those who don't, it's an excellent tool for network debugging. You can connect your device to Charles. It's acting as a bridge with a Wi-Fi connection, and you can capture all the information that has been sent. For example, if I came here, I can see that all the network requests I'm sending. So I can see the code I'm getting back. I can see the response I'm getting from the server. In this case, I'm getting, this is just a very standard web service I wrote. It's always returning a code, a message, and a key. But I've seen in many companies while consulting that they are not using HTTPS because they have, you need to get certificates, and that's expensive. This is what you're facing. You could very easily connect this with Wireshark, poison the network, and being able to access tokens, passwords, if they are not encrypted, etc. So back to Genymotion. I'm going to take here one. Okay. Still not working, but as I told you, I took the pictures before. If I come here to the file manager, I have here the folder SnapHack. And you can see that one of the pictures has been taken. This one has been encrypted. So when I type here, I cannot see it. With this framework Council, I can encrypt the picture and only be able to read it from the application. Okay, that has been the first demo. I'm going to make one now, a little bit more complex, with a Hello World application. I will make some code injection. I will show you how the application can be decompiled and how the code can be injected. So here I have a Hello World file that I will install. Okay. Let me uninstall what I have here. Okay. Okay, this is a very simple file, right? I have a hello world with a text view that says hello world Android. What I'm gonna do is uncompile and make code injection inside. What do I use to uncompile? So there is the application I'm gonna use is called APK tool. You just can Google and download the last version. Basically, this APK converts from the APK file that has been already compiled into Smiley. Here we need to type the name of the file we want to uncompile. And we need to write also the parameter d, that means decompile. Good. So now if I came here, for example, in Hello World, this is the result of what I have done. If I came, there is a Smiley folder. We can see here that there are some Smiley files. We also can see the R, the resource file. We can see all the inner classes. This is the attribute, draggable. This is a very basic example, but as we can imagine, if we uncompile Facebook, for example, there would be many classes. Let's go now open Hello World activity to see how it looks like. Okay. Sometimes opening things with Xcode can be a little bit scary because it opens the entire environment, but no, this time goes great. So if we read the file, and we've been programming with Android, some things make sense, right? We can see that we have a constructor. We can see that this is the source file. This thing from here looks like this is the superclass, right? The superclass is, so this class, Hello World activity extends from activity. We have a virtual method, so the virtual methods are the ones that we are defining, like onCreate, right? If you have been programming with assembler, this will look similar to you, because we put in some registers the variables, then we can add some values. So if we read here, we see that we have a text view. The text view has a string. Looks is very interesting that the string is not encrypted unless we use another measures, but we can access here the resource directly. We can make something like Hello World iOS. And yeah, I actually want to make an example of code injection. It's a little bit more complex, so I wrote it here in another file. And what is code injection? Code injection is when we take functionality that we have written in another application and show it. In this case, I'm going to make something very easy and very simple, which is taking a toast, putting the toast into the application and recompiling. But we can imagine that this has many different possibilities. We could insert ads with our own ad ID. We could insert a keylogger that is logging everything we're typing. We could insert some module that takes the personal information, credit cards, etc. on the background and sends also as well to a different web service. So that's one lesson from today as well. Do not download applications from obscure resources, because you see how many things we can do. So now that this file has been saved, I will come here again. And again, with the APK tool, I will recompile the application. I need to use the parameter b, and now the folder where this has been stored. And now we see that if everything worked, we have now in the folder dist a new APK. So now I'm going to install this new APK, or do I need to do something? Can you think of something that I still need to do to make the application work? Right, yeah. If I don't see it, it will not work. So let me remove this application. So also because sign-in is such a long line, I already put it here. Yeah, so with jar signer, I will use a key store. I have created there, password 126. Jar has been signed, so now I will install the Hello World. And have you seen? The toast and iOS. So starting with an application, I have made some code injection, and the application is working now with the same certificates, etc. Okay, that's the first demo of reverse engineering. Now, let's gonna show some demo on, with a CrackMe. A CrackMe is basically an application that It's used for in cracking context. So people design a crackme. The crackme is designed, as you can imagine, to be cracked. Well, people try to, there are always like a lot of contests with crazy people using crazy obfuscation and crazy systems to store the information. This is a very easy one, because obviously we don't have a lot of time, just so you get the context, a little bit the concept of how crackme works. I'm going to use a similar technique. So here we have to enter a name, we have to enter a serial number. If the serial number is not working, we get a toast that says bad boy. If the serial number is working, the application will allow us to use it for free, even if it's a crackme. And now let's gonna use a different tool. This time I will use a tool called text2jar, which should be here. Yeah. So text2jar basically takes an APK file and converts it into a jar file. Jar files are very easy to decompile. We will go a little bit more into that. But yeah, basically I will call this thing from here. Let me see where I have the crackme. Okay. So the command I'm calling is from text2jar, please transform this APK into a jar file. Now I have this jar file here, and I will open it with GD guy. GDG is a Java decompiler. It can be used for Java files and as well from Android files when they have been transformed into Java. And when it has been transferred, now we can see the code in Java, and it's not a translation, so text2jar doesn't make it a perfect translation, but we can see that we can understand some things here, right? So there is a telephony manager that takes some fields from the device. It takes a substring, that another number that gets the device ID, the SIM serial number. Then we make some compromission, like if this string plus this symbol from here, let me zoom in, plus another string and another symbol, if that's good, then show something that says good boy. As I said, it's not a perfect translation, so when we are using text2jar, we need to put it into our Android Studio compiler. We need to go line by line. There are things that doesn't make sense, like this return here, or this, there are a few things like a continue, we don't need a continue here, etc., or an int at the end that nobody's going to read, but we can understand a little bit what it does. I took that, I made that job already for you, and I put this into a file that is compiling. Yeah, exactly, this one from here. And in this one, I also type this string from here is the one that we are typing on the screen. So if we open this with Android Studio and we execute, we will go on the while through, etc. And at some point, we will reach a number similar to this one. So if now I came here to the emulator and type this thing from here, I will say good boy. So it's, by the way, good, not God. But yeah, you see you get the main point, right? It's if we are not using obfuscation, it's very, very easy to decrypt those applications. I have a couple of commercial examples. One of them is SwiftKey, a very old version. Now SwiftKey is using ProGuard. But we can see this is SwiftKey being uncompiled. We can see we came into its own packets, and we can hit into touch type that pretty much we can read all the classes. There is nothing very, very hidden here. We can see in the constants that we can see all the numbers, how they're stored. That's very interesting because we can look actually for HTTP calls. If we can here and go to search, and try to search for a HTTP pattern in a string constant, then, yeah. So all those things are things that are matching. Yeah, pretty much we can see that there are many constants. We could see when tokens are being stored. We could modify the tokens. We could try to call directly the web services and see which effect is having, etc. And yeah, the way there are two main ways to, or a few ways I explained before to get protected from this. One is to use ProWare, but as we have seen, ProWare has this big problem that is not encrypting strings. If we want to encrypt or obfuscate strings, I can think of two main ways. One is using DexWare. It's a commercial solution, but it applies obfuscation on a string, so when we are decrypting, the application is not being shown. And another one is using NDKey. How many people here has experience with NDKey? How many of them have used it for security purposes? Okay. And normally nobody puts the hand up, so that's already a good number. With NDKey, we compile files into object files that can still be decrypted. So we can call the O file with the name of the function, and the function will return us, will actually return us what is returning, but we can make a use of entropy. That means if we want to generate a token that is going to communicate with a server, we could take values of the phone that are never the same and cannot be reproduced. For example, the local time or the amount of RAM being used, etc. We can create a hash with all this information being sent to the server, and the server will speak the same language. So they can understand that they are communicating between each other, and this is critical for applications like banking or PayPal or things that are involving money, because we get rid of all the possible attackers that put Wireshark in the middle and make a man-in-the-middle attack and take all our data. Okay. So, yeah. I think that's been everything. I will upload all the code on my Twitter. And I love feedback on talks, so I can see what things can improve, what the audience like and not. If I have prepared this small formula here. If you leave me your feedback, I have created this bit.ly address, feedback Droidcon IT 16. I will give to one of the persons that leave feedback a book I wrote with 100 questions and answers to help you land your dream Android job, which I think is a very good book. And yeah, anything you need, feel free to write me at any time. I will also be at the app clinic most of the day, so you can get in there if you have any question or you want to talk. Thanks for being here, and if you have any question or something you want to talk about, something that was not clear, just raise your hand and I will be happy to answer. This one? Up. No questions? Okay, then. Came later if to the app clinic. Let's gonna have a talk, and thanks everybody for being here. It's been wonderful.